And here's the last example from 9.1-2 final, so example number 3. Halley's Comet is moving at a velocity of about 1 times 10 to the third meters per second when it is at its furthest point away from the Sun, 5.3 times 10 to the 12th meters. What is its velocity at its closest point to the Sun, 8.8 times 10 to the 10th meters? Similar to our documenting first what our given information is, V1 is equal to 1 times 10 to the third meters per second, or 1,000 meters per second. R1 is equal to 5.3 times 10 to the 12th meters. R2 is equal to 8.8 times 10 to the 10th meters. Similar to our first example problem, this is a conservation of angular momentum problem. So we begin with L1 equal to L2. We follow with the initial substitution. L equal to I omega, and therefore L1 is I1 omega 1 and L2 is I2 omega 2. Making the same substitution we did on example problem number 1, I is equal to mr squared. This gives us mr1 squared omega 1 equal to mr2 squared omega 2. Another substitution we can make, because while we have r1 and r2, we do not have omega, we have v. Going back to our rotational motion equations, we had that v was equal to r omega, or omega is equal to v divided by r. When we substitute that in, we get omega 1 becomes v1 divided by r1, and omega 2 becomes v2 divided by r2, giving us m r1 squared times v1 over r1 equal to m r2 squared times v2 over r2. M cancels out on both sides, as it did before. Now what ends up happening next is that since I have r1 squared in the numerator and r1 in the denominator, the r1 in the denominator cancels out and the square in the numerator is gone. Same thing happens on the right side with r2. This leaves us with r1 times v1 equal to r2 times v2. Rearranging this, solving for v2, requires us to divide by r2 on both sides, leaving us with v2 equal to r1 times v1 divided by r2. Substituting our information, our given information in, gives us 5.3 times 10 to the 12th times 1 times 10 to the 3rd, divided by 8.8 times 10 to the 10th. Calculating this gives us 60,227.27 repeating. Going to only one significant figure, because that is what 1 times 10 to the 3rd had, rounds this to 60,000 meters per second.